I watched Richard Feynman look at a physics problem the way you look at a chair. Not think about it, not calculate it, look at it. Then he wrote 4 lines, and he was done. I had spent 3 days on the same problem. My name is Freeman Dyson. I was the man who watched Richard Feynman do things that should not have been possible, and I was the man who proved to the world he was right, when every expert said he was wrong. Let me tell you what I saw, because I was 3 feet away when it happened. I arrived at Cornell University in September of 1947. I was 23 years old. I had an undergraduate degree in mathematics from Cambridge, and a reputation for being one of the best in my class. What I did not have was any preparation for what I was about to see. The first thing I noticed about Feynman was that he seemed, frankly, like a man who was not working very hard. He was warm. He was funny. He laughed too much. He drummed on tables. He told jokes. He spent what appeared to be an alarming amount of time not doing physics. And then, I started watching what happened when he did. My supervisor at Cornell was Hans Bethe. If you wanted to understand what genius looked like in 1947, you watched Hans Bethe work. He was fast. He was disciplined. He was methodical. He could take a problem of enormous complexity and reduce it, step by careful step, to an answer. I had never seen anyone calculate like Bethe, until I watched Feynman. Bethe would work through a quantum electrodynamics problem across 3 full pages of calculations. Feynman would sit across from him, look at the same problem, and write 3 lines. The same answer. 3 lines. I watched Bethe's reaction the first time I saw this happen. He did not look surprised. He shook his head slowly, the way you shake your head at something you have accepted, but never quite understood. He had seen it too many times. That was the thing that stayed with me. Even Bethe, who was faster and more powerful than almost any physicist alive, had given up trying to understand how Feynman did it. He had simply accepted it, like weather. There was one afternoon at Cornell that I have never forgotten. Feynman was working, not writing, not calculating in the normal sense. He was talking out loud to no one in particular. Ideas were coming out of him the way water comes out of a pipe, continuously, effortlessly, with no visible source. I later wrote about that afternoon. I wrote that Feynman produced more brilliant ideas per square minute than I have ever seen anywhere before or since. I have known Oppenheimer. I have worked alongside Einstein at Princeton. I have sat in seminars with Bethe for an entire year. I have seen what genius looks like from close range. That afternoon at Cornell was different from all of it. And here is what puzzled me most. Bethe and I were both calculating the same things Feynman was calculating. We were working on the same problems, using the approved mathematics, following the established methods, and we were getting the same answers as Feynman. But Feynman could do things we could not. There were problems Bethe could not solve that Feynman solved immediately. Not because Feynman was faster, but because Feynman's approach gave him access to something our approach did not. Neither Bethe nor I could explain why. That is when I started paying close attention to what was actually happening when Feynman worked. And I realized something that shook me. Feynman did not think in equations. He thought in images. He could see what the particles were doing, not as a metaphor, not as an aid to calculation. He literally perceived the behavior of electrons the way you recognize the face of someone you have known for years. He saw it. Think about what that means. Every other physicist in the world started with symbols and worked toward a physical picture. Feynman started with the picture. The mathematics came afterward. It was translation, not creation. The mathematician Mark Kac once said there are 2 kinds of genius. The ordinary genius is a fellow who is much better than you and I, but not beyond understanding. Then there is the magician. The magician does something that cannot be reconstructed, something you cannot follow even after you have seen it done. He said Feynman was a magician of the highest caliber. I watched that magician get rejected by the entire physics establishment, and I want you to understand what that looked like. In the spring of 1948, Robert Oppenheimer organized a conference in the Pocono Mountains of Pennsylvania. 28 physicists were there, the complete constellation of the field. Niels Bohr, Paul Dirac, Julian Schwinger, Feynman's great rival. The people who had built modern physics were in that room. Feynman was asked to present. He stood up and began to explain his diagrams, his pictures, his private visual language that he had built entirely inside his own mind over 8 years of work. Nobody understood a word. Not one person in that room could follow him. He was speaking a language from no textbook, a language no one had taught him because no one else had it. He was trying to explain it in real time, without the written papers that would have made it clearer, to the most skeptical audience on Earth. At the end, Oppenheimer stood up. Think about who Oppenheimer was. He had run the Manhattan Project. He was the most powerful figure in American physics. When Oppenheimer made a judgment, careers moved around it. He said Feynman's presentation had been confused, that the approach was not rigorous, that it needed to be rebuilt, and that was that. Nobody understood a word that Dick said. At the end, Oppenheimer made some scathing comments. Dick came home from the meeting very depressed. That summer, something unexpected happened. Feynman was driving from Cleveland to Albuquerque, 1,800 miles across the American West. He offered to take me along for the ride. I said yes. We drove through Ohio and Oklahoma in 3.5 days, through small towns, country roads, and flat plains that went on further than I had expected. During a massive rainstorm in Oklahoma, we got stuck and spent a night in a motel that was something between a roadhouse and a brothel. Feynman managed to get us a room. Of course he did, and the whole drive, Feynman talked about physics. He talked about electrons the way other people talk about places they have been, with familiarity, with warmth, with the certainty of someone who had spent so much time there that it was personal. He described how a particle explores every possible path between 2 points, how some paths reinforce each other and some cancel, how the universe runs a vast invisible democracy of possibilities that collapses into a single observable event. I knew the same physics. I had read the same books. I had passed the same exams. But I had never heard it described like this. You could feel that he was not explaining it to me. He was remembering it, the way you remember a room you have been in 1,000 times. Think about that. The man who could not make a room full of Nobel laureates understand him was the same man who could make an entire theory of the universe feel like something you had always known. When we arrived in Albuquerque, we were pulled over for speeding. We paid the fine. We drove on. From Albuquerque, I traveled north to Michigan, to Ann Arbor, to spend 6 weeks attending Julian Schwinger's lectures. Schwinger was Feynman's great rival. His approach was the opposite: formal, densely mathematical, no pictures. I was one of the only people in the world who had spent real time with both of them. Then I boarded a Greyhound bus to Princeton. I had been on that bus for more than 48 hours. Somewhere in the middle of the country, going into the kind of stupor that comes from 2 days without sleep, I began thinking very hard about physics, about Feynman, about Schwinger, about the two theories that looked completely different on the surface. And then, suddenly, I saw it. I later called this a flash of illumination. Everything clicked into place at once. The two theories were the same, different language, same deep truth. I understood, in that moment on that bus, what Richard Feynman had been doing for 8 years. When I arrived at Princeton, I sat down and wrote the most important paper of my career. I proved that Feynman's approach, his private visual language that no one at Pocono had understood, was mathematically identical to Schwinger's approach, to Tominaga's approach. I sent it to Oppenheimer. Oppenheimer did not believe it. He arranged for me to give a series of seminars at the Institute for Advanced Study. Each time I presented, each time I showed the equivalence, Oppenheimer would intervene. He would challenge. He would use his full authority and intelligence to stop the argument. Weeks passed. The seminars continued. Nothing changed. Then Hans Bethe came to visit from Cornell. Bethe sat in the audience. He listened. At the end, he turned to Oppenheimer. "Dyson is right," he said. Oppenheimer accepted it. By 1949, at the next major conference, The official notes described Richard Feynman, 30 years old, as the leading physicist of his generation. The diagrams that no one at Pocono had understood became the universal language of particle physics. Today, every physicist in the world uses them. Every calculation involving the fundamental particles of nature is written in Feynman's private language, the language he built alone, inside his own mind, that no one had believed. The theory itself became the most accurately verified scientific theory in the history of science. You want to know what that means? Imagine measuring the distance from New York to Los Angeles and being off by less than the width of a human hair. That is how accurate Feynman's theory is. He won the Nobel Prize in 1965. A reporter called him at 3:45 in the morning to tell him. The reporter asked, "Aren't you pleased to hear that you've won the prize?" Feynman said, "I could have found out later this morning." Of course he did. I spent 40 years as his colleague. I drove across America with him. I fought Oppenheimer for him. I was the one who translated his private language into words the world could read. And I still cannot tell you how he did it. Not really. I know the facts. I know the conferences, and the papers, and the prizes. I know the room that told him he was wrong, and the bus where I realized he was right. But the thing itself, the thing that let him look at a particle and see what it was doing, the way you look at a friend's face and know what they are feeling, that thing I do not know. I have thought about it for 70 years. I watched Richard Feynman look at a physics problem the way you look at a chair. Not think about it, not calculate it. Look at it. The room said no. No one thought like him. They were wrong. And the diagrams he drew alone, before anyone believed him, are how we understand the universe today.